Good morning, students. I assume that you have attended the last 6 lectures on number system. This is the 7th lecture in which we are going to learn about unit digit. Well, we all know what unit digit is. Over here, the unit digit is 4. Over here, the unit digit is 6. But the problem arises when they say, let's say, so and so to the power 468, and they ask what the unit digit would be. Now, these are very simple questions. Let's take 10 minutes of the lecture and you will be able to solve such questions with ease. Now, as the statement says, if you have unit digit as 0, 1, 5 or 6, no matter what the power is, the final answer would give you the same unit digit. Let me explain. As you can see, the unit digit over here is 0. As I said, no matter what the power is, the unit digit for the final answer would be 0 only. In this case as well, it would be 0. Unit digit is 6. Unit digit is 6. No matter what the power is, the unit digit over here would be 6. Over here it would be 5, 1. Now, this might sound and seem complex. So many numbers over here. As I said, no matter what the power is, if the unit digit is 0, 1, 5 or 6, the same unit digit would be of the final answer. Simple as that. Now, let's talk about 2 to the power n. 2 to the power 1 equals to 2, 4. 2 to the power 3 is 8, 16, 32, 64, 128, 256, 512. Now, if you observe, there is a cycle which repeats at the interval of 4. 1, 2, 3, 4. If you observe, every fourth number has a unit digit 2. Every fourth number has a unit digit 2. Similarly, every fourth number from second place has a unit digit 4. If I talk about the third place, every fourth place have a unit digit 8. That means we can say there is a cyclicity of 4 going on with power, and there is a repetition of unit digit. So what if they ask us what the unit digit for 2 to the power 9 is? Although we know that would be 2 only, but let's try to solve it another way without so much of calculation. What we'll do is we will divide 9 by 4. That would be 2 times 8 and the remainder is 1. So we can say that when we divide 9 by 4, it gets completely divided, leaving remainder 1. So now we are not going to find the value for 2 to the power 9. We are going to find the value for 2 to the power 1. And unit digit for 2 to the power 1 is 2. Therefore, the unit digit for 2 to the power 9 would be 2 only. Let's solve one more question. Let's say 2 to the power 53 or maybe 54. What we do is we divide it by 4. Divide the power by 4. Why? Because there is a cyclicity of 4. We divide 54 by 4. We get a remainder 2. We write 2 to the power 2 and we do not care about the actual value for 2 to the power 2. Just say that the unit digit for 2 to the power 2 is 4. So the unit digit for 2 to the power 54 would be 4 itself. Now the question is, do you need to learn the cyclicity 2, 4, 8, 16? No, we will learn that as we go. We don't need to actually actively learn it. Now, similar goes for the power of 3. As you can observe that the cycle gets repeated. at every fourth interval. 3 to the power 1 is 3. 3 to the power 5 is 243, which ends with the unit digit 3. Same goes for 4. The cycle repeats at every fourth interval. So we'll use the same method. Now, sir, what about 7? Well, we are not going to learn all the powers of 7. What we are going to do is 7 to the power 1 is 7. 7 to the power 2 is 49. We'll just write 9 over here, unit digit. Now, in order to find 7 to the power 3, what we'll say is 49 times 7. No, we are just going to use 9 times 7. That is 63, left with 3. Again, multiply 7 to 3. We are going to get 1. Multiply 7 to 1. We are going to get 7. And as you can very clearly see, the cyclicity goes on with an interval of 4. Same goes for 8, I'd say. 8, you multiply 8 to 8, you get 64. You multiply 8 to 4, you get 32. You multiply 8 again, 6. Multiply 8 again, you get 8. The cyclicity repeats at every fourth interval. So, all the numbers 2, 3, 4, 7, and 8 goes on with the cyclicity of 4. Let's talk about the cyclicity of the numbers ending with or unit digit 4 or 9. You can see that the cyclicity repeats at every second interval. Same goes for 9. 9, you multiply 9 to it, again multiply 9 to it, 9 to multiplied 9. You can see that it repeats a cycle of 2. So, if we are given a question, let's say 4 to the power 97, how do we calculate it? If we are supposed to find the unit digit, how do we calculate it? We say, let us divide 97 by 2. We know that the remainder anyway is going to be 1. That will be 4 to the power 1, which gives us 4 as our unit digit. Now, we don't need to actually divide by 2. Although we needed to divide by 4 in the earlier cases, we don't need to divide by 2 over in here. If you observe, there is a case of even and odd. There is a case of even and odd over in here. If you observe, all the numbers having power odd gives us 4, and all the numbers having power even gives us 6 as our unit digit. Don't need to learn that again. As I said, how do we calculate it? We don't know. What we'll say is 4 to the power 1 is 4, 4 to the power 2 is 16. Just need to learn that there is a cyclicity of 2 going on. You say, sir, since this power is odd and we know that odd power gives 4, the unit digit would be 4 itself. Let's solve one more. Let's say you are given 9 to the power 87 times 96 times maybe 93 times 31. You are supposed to find the unit digit. What you say is, since all the powers are odd and we know that odd multiplied by odd gives us odd only. So this entire thing would be odd, and we know that 9 to the power odd gives us 9. If you don't remember, you'll say, let's say 1 is odd and 9 to the power 1 is 9. So we'll say the unit digit to be 9. Simple as that. Now, What we have learned till now is if we write all the numbers from 0 all the way up to 9, we see that 0 and 1 repeats at a cyclicity of 1. That means all the number having unit digit 0 would give us unit digit 0. Same goes for 1, 5 and 6. 4 and 9 repeated at a cycle of 2. That means we used even and odd in this case. We check the power if they are even or odd and answered accordingly. About 2, 3, 7 and 8, we saw that there is no way out. We actually need to divide it by 4 and we'll get our answer. Now there is a hook actually. There is a hook. Before I tell you that, you need to learn this fact. There is no difference between 0 or 4 when it comes to remainder. Let's say if I ask 4 to the power, or maybe let me change that, 3 to the power 96, what will be the unit digit for this one? You'll say 3. 96 gets divided completely by 4. We know that we are supposed to divide the power by 4 because 3 has a cyclicity of 4. We can very clearly see that it gets completely divided and there is no remainder. 3 to the power 0. That does not make sense because that would be 1. So what we say is whenever we get 0, we write 4 over here. We write 4 over here. And now let's count what the unit digit for 3 to the power 4 is. We know that it starts with 3, multiply 3, 9, multiply 3, you get 27, just write 7. Again multiply 3, you get 7 3s are 21, 1 as your unit digit. That is your answer. Unit digit for 3 to the power 4 as well as 3 to the power 96 is 1. Simple as that. Now let's solve a few problems. I'd say I assume that you understood all the concepts how to solve those problems. We solve some problem, your concept will be much more clear. We are given 2 to the power 51. What we say is divide 51 by 4. We know that we are going to get 48. No need to find the quotient. The remainder is 3. We'll say 2 to the power 3. And the unit digit for 2 to the power 3 is 8. So option B would be correct. Next. Now before we solve this question, I'd like you to know, what if we multiply, let's say 1962 times 1000, and I ask you the rightmost non-zero digit. You multiply this and you say the rightmost, from a right, the non-zero digit is 2. Again, if I give you this and ask you what the rightmost non-zero digit is, you'll say this is 0, 0, 0. The first non-zero digit from the right is 2. My question is, did you really needed to multiply this? You knew that all the zeros won't be counted. So we should not have seen and taken this in the first place. We just have taken this number and would have said 2 is our rightmost non-zero digit. Similarly, in this question, it says the rightmost non-zero digit of the number so and so. Shall we write 30 to the power 29, 28 as 3 to the power 29, 28 multiplied 10 to the power 29, 28? Simple as that. Now, we are not going to talk about this section because that would give us 0. We don't need to find the 0 digits. We are supposed to find non-zero digits. We'll talk about this one. We need to divide 29, 28 by 4. That would be 28 and 12 cancelled. 8 would as well be cancelled. So this gets completely divided. So we'll say that 3 to the power 0 is over there because the remainder is 0. But we know that we cannot say that. We'll have to change this 3 to the power 0 to 3 to the power 4, and 3 to the power 4 ends with 1 as a unit digit. So option A would be correct. The question states, find the thousandth position of 5 to the power 3 multiplied 2 powered 1001. What we'll say is, can we write this as 5 to the power 3 multiplied 2 to the power 3 multiplied 2 to the power 998? Why? Because the power would get added and we'll anyway get 2 to the power 1001. Now, if you observe, 5 to the power 3 multiplied 2 to the power 3 would give us 10 to the power 3 multiplied 2 to the power 998. Now, what if I say, what would be the value for, let's say, 2 to the power 5 times 10 to the power 3? You'll say 32 times 1000, that is 32,000. And you were supposed to find the thousandth position of the digit. So thousandth would be ones, tens, hundred, and thousand would be 32. So as a matter of fact, even if we would not have multiplied it by 1000, we would have gotten 2 as our thousandth position digit. Similarly, there is 1000 over in here. We are not going to talk about this. We'll just use this and get the unit digit for this one. That would be the thousandth position of the entire number. Let us divide 998 by 4. We'll get 8, 19, 16, 38. We'll be left with 2. 36, right? We'll be left with 2. So we'll say this can be written as 2 to the power 2, and the unit digit for this one would be 4, and that as well would be our thousandth position digit, which is option C. Next question. We are asked to find the unit place for the given number 2153 to the power 167 times 8267 to the power 153. What we do is we try to find the unit digit individually. We divide this by 4, we get remainder 3, right? We use the unit digit only, 3 to the power 3, right? 167 divided by 4 would give us 164 and 3 as a remainder. We just used unit digit because we are supposed to find unit digit. Multiplied, again we'll use the unit digit only, and we'll divide this entire thing by 4. We divide this, we get 12 and 33, 32, left with 1. So that would be 7 to the power 1. If you solve this, you know that 3 to the power 3 gives us 27, but we are going to talk about unit digit only. Unit digit for this one would be 7, and unit digit anyway for this one would be 7. You multiply that, you are going to get 49, but we are just going to take unit digit. Unit digit for 49 would be 9, which is option D. Next question. I guess you are understanding the concepts, which is more important. Now this question looks very complex, so many numbers over here, so many exponents, but I'd say the answer is very simple. As you can see, it has 2 over in here. Whatever the power of 2 would be, it would always give us even. Whatever the power of 5 would be, it would always give us 5. And we know that when even is multiplied to 5, it always gives a unit digit of 0. Say even is 2, 4, 6, 8, even 0, the unit digit would be 0 when multiplied by 5, right? So our final answer would be 0. Next question. What is the unit digit? What is the unit digit for so and so? Since they are talking about unit digit, we'll just take the unit digits from over here. That is 7, 9, 4, and 2. Alright? Now let's talk about its power. Now, I like to go back a little bit. Let's copy this one. Alright. If you remember, 7 had a cyclicity of 4. You need to learn this, by the way. What we are going to do is, we are going to divide the power with a base 7 by 4 because it has a cyclicity of 4. 413 divided by 4. Again, you don't need to divide the entire thing, just need to divide the last 2 digits. If you observe, we are going to get remainder 1. So we'll write 7 to the power 1. 9 has a cyclicity of 2. So we'll say, we just check even or odd. This section is odd. We'll write odd over in here. 4 has a cyclicity of 2. That means we are going to talk about odd even. As we can see, this is even. We'll just write even over in here. And 2 has a cyclicity of 4. So we'll say over here, there is 2. We'll have to divide 812 by 4, sorry. We get remainder 0. Now, that is not enough. We don't write 0 as our power. We always write 4 instead. We'll have to solve this. We'll say 7. 9 to the power odd. If you don't remember, you'll say just 9 to the power 1. 1 is odd, gives us 9. So the unit digit in this case would be 9. 4 to the power even. 4 to the power 1 is 4, but 4 to the power 2 is 16 with the unit digit 6. And 2 to the power 4 is 16, which gives us 6 as our unit digit. We are supposed to find unit digit. What we do is multiply these two. 7 9s are 63. We get a unit digit 3 over here. 6 6 are 36. We get a unit digit 6 over here. We multiply these two and we get 18, which has a unit digit 8, which is option D. Simple as that. Now, may look a little bit complex, but I promise it is not. I'd say this is the last question. No, last second question. 3 to the power 98 minus 3 to the power 89. We can very clearly see that 3 has a cyclicity of 4. So we will divide the power by 4. 98 divided by 4 would give us 2 as our remainder, and 89 divided by 4 would give us 1 as our remainder. That would be 9 minus 3, which is 6. So our unit digit would be 6. Simple as that. Okay, now this question. Again, this looks complex. It is not. Let me write the question for you so it becomes a little bit more clear. All right. We are just going to take unit digits because they have anyway asked about unit digit. We'll take the unit digit, which is 5. And if you remember, 5 always gives 5, no matter what the power is. So we'll just write 5 over here. 3 has a cyclicity of 4. So we'll have to divide 469 by 4, actually just the last 2 digit, and we get 1 as our remainder, multiplied by, again we'll write 9, and 9 takes the cyclicity of 2. We'll talk about even or odd. We can see this is even, we'll just write even over here, minus 4 takes a cyclicity of 2. We'll write odd over here, multiply 7 takes a cyclicity of 4. So we'll have to divide this entire thing, 935 by 4. 35 divided by 4 would give us 32, and 3 would be our remainder, right? Now 5 plus 3 anyway would be 8. 5 plus 3 would be 8, multiplied by 9 to the power even gives us 1. Gives us 1. If you don't remember, you would say 9 to the power 2 is 81. So the unit digit is 1. 4 to the power odd gives us 4 only. 4 to the power 1, 1 is odd over in here, gives us 4. Multiplied by 7 to the power 3. Remember 7 square is 49, that gives us 9. And you multiply 7, you get 63, which is 3 over in here. You'll write 3, right? Now 8 multiplied minus 3 times 3. Again, whenever you encounter such minus 3 or something, what you say is, of course, unit digit can never be negative. What you do is, you add this negative to 10. You get 7. So now you get 8 times 7 times 3. How do you find the unit digit? You say 7 3s are 21. Unit digit 1 multiplied by 8 gives us a unit digit 8, which is option D. Simple as that. It would take you barely 25-20 seconds to solve such questions. If you are proficient enough in it, this was the concept. If you understood the concept very well, go try some problems. And if you did not, revisit the concepts and understand them thoroughly. If you like the video, please like it, subscribe, and do comment your suggestions. Thank you. Have a nice day. We'll see you in the next class.